Hi, I'm Homer A. Dapada from BSIT IT2M1.
Hi, I'm Sarla Nimuenano from BSCS IT2M1, here together to present a final submission for CC4 Data Structures and Algorithm from Mr. Louis Agustin.
Hi, I'm Homer E. Dapadap, discussing the bubble sorting introduction. What is data structure? But first, in computer science, a data structure is a data organization, management, and a storage format that enables efficient access, and modification more precisely. A data structure is a collection of data values, the relationships among them, and the functions or operations that can be applied to the data. And what is algorithm? A process or a set of rules to be followed in calculations or other problem-solving operations, especially by a computer. A basic algorithm for a division. Bubble sorting. What is bubble sorting? Bubble sort is a basic algorithm for arranging a string of numbers or other elements in a correct order. The method works by examining each set of adjacent elements in the string from left to right, switching their positions if they are out of order. For example, the bubble sorting, bubble sort in the selection sort. Example, the sample flow is the entered value.
Hi, I'm Zarla Nimuenano, here presenting about the binary tree traversal. So what is a binary tree traversal? First thing is, a binary tree is a finite collection of elements, or it can be said it is made up of nodes, where each node contains the left pointer, right pointer, and the data element. The root pointer points to the topmost node in the tree, while tree traversal is the process of visiting each node in the tree exactly once. Visiting each node in a graph should be done in a systematic manner. There are three basic types of tree traversal. The first one is the in-order. The second is pre-order, while the third is the post-order. As we can see, the rule in order follows the left, root, and right, while in pre-order, we first follow the root, left, and right, while the post-order follows left, right, and lastly the root. Here in the following given, we follow the 1, 4, 5, 6, 8, 10, 11, 13, 15, 24, 28, 30, 32, 36, and lastly 38. As we follow the rule, it is left, root, and right. So we first start at the left. So it must be 13, then 6, 15, 4, 24, 8, 28 for the left side, while the root will be 1. As we proceed to the third, which is the right side, it must be 30, 10, 32, 5, 36, 11, and 38. The final output will be 13, 6, 15, 4, 28, 8, and 28 as per the left side of our tree in order traversal, while the root will be 1. So, it should be on top, just like what we've seen earlier. While for the right side of our tree, it indicates that 30, 10, 32, 5, 36, 11, and 38. So it's done. The next is pre-order, which is the root first, left, and right. So, as we follow, we will going to select the root first. So the root is the 1. The next one is the left side, which is the 4, 6, 13, 15, 8, 24, 28. And as we proceed as the right side, we will going to do just like what we do earlier, which is the 5, 10, 30, 32, 11, 36, and 38. For the final output for pre-order traversal, the root, which is the 1. For the left side, it is 4, 6, 13, 15, 8, 24, 28. And as per the right side, it is 5, 10, 30, 32, 11, 36, and 38. The next one is the post order, which is the left, right, and root rule. As the first principle, we will going to follow about the left. Left first. The first is 13, 15, 6, 4, 24, 28, and 8. The second principle is the root, which is the 1. The third will be on right side. So it must be 30, 32, 10, 5, 36, 38, and lastly 11. The final output would be 13, 15, 6, 4, 28, and 8 as per the left side. As per the right, it should be 30, 32, 10, 5, 36, 38, and 11. Sorry for the typo error, but the 1 would be erased here because as per the rule, it is last. So it must be 1, 11, then follows by 1. The final output is here. Queuing. So what is queuing? A queuing is an abstract data structure movement similar to stacks. Unlike stacks, a queue is open at both its ends. One end is always used to insert data, which we called enqueue, and other is used to remove data, which we call the queue. Queue is a linear type of data structures, follows the FIFO methodology, which is first in, first out. The operations in queuing is enqueue. Queue is the insertion or addition of an element in the queue, while the queue removes the element from the queue. There's this front, which is the first position in the queue. Other term for front is the rear. And the back, which also calls the tail, is the last position in the queue. Here in the image, it is clearly shown what was happened and how the operation is applied. In the queue, we remove an element, and as we see, an element is removed. And then in queue, an element is added. For an example, in the given integers are 3, 5, 1, 6, and 7. So as I put these integers in this queue, I will going to put the 3 in the rear. So this will serve as the first element. 5 is the second element in the queue. 1 is the third, 6 is the fourth, and 7 is the fifth element. So, if I will going to remove 3, then this process will be called the queuing. And if I going to add from this line 8, then it is the process of enqueuing. Let's imagine that 3 is not here. Then 5 will be the new rear element. 1 is the second, 6 is the third element, 7 is the fourth element, then 8 will be the fifth, which positions in the tail. So here is the sample source code for our given. Just like my example earlier, it shows the integer is 3, 5, 1, 6, and 7. So it clearly shows that 3 is the first integer. So as shows, these integers undergo enqueuing. The head, which is the 3, goes to deletion, which is the process of dequeuing. Then, the new queue is 5, 1, 6, and 7. Now, the head will be the 5. That's all. May we go to the next presenter.
Stacks. Stack is an abstract data type, or an ADT, commonly used in most programming languages. It is named stack as it behaves like a real-world stack. For example, a deck of cards or a pile of plates, etc. For example, a real-world stack allows operations at one end only. For example, we can place or remove a card or a plate from the top of the stack only. Likewise, stack ADT allows all data operations at one end only. At any given time, we can only access the top element of a stack. This feature makes it LIFO data structure. LIFO stands for last in, first out. Here, the element which is placed or an insert
subtracted or added last is assessed first. In stock terminology, insertion operation is called push operation and removable operation is called pop operation. And the example is this. The basic operations, stack operations may involve initializing stack using it and then initializing it. Apart from these basic stuffs, a stack is used for following two primary operations. Push, pushing or storing an element on the stack, and pop for removing or accessing an element from the stack. When data is pushed onto stack, to use the stack efficiently, we need to check the status of stack as well. For the same purpose, the following functionality is added to stacks. Pick, to get the top data element of the stack without removing it. Is full, check if stack is full. Is empty, check if stack is empty.
Hello, I'm Homer the Padap, evaluating the program constructed by my pair for this video, Miss Zarlene Yunanyo. I will going to show you guys on how this code works. But first, the language used in this code is C language. The main menu, under the main menu, it contains sorting for the first choice, then binary tree traversal for the second choice, then queuing for the third choice, stockings for the fourth choice, and fifth choice is about, and for the sixth choice is exit. And first, this source code contains the sixth choice in the main menu. Run. Then for the example is sorting. Choose one, enter. Then bubble sort. Enter 5 integers, for example 3, 5, 6, 7, 1. The example 5 integers, enter. Then the bubble sorted numbers is 1, 3, 5, 6, 7. The bubble sorted numbers raised into ascending order, which is 1, 3, 5, 6, 7. Then the binary tree traversal. Click 2, enter. Enter the first integer. For example, is 1, 3, 5, 6, and 7. Enter. Then the pre-order traversal of the binary tree of 1, 3, 5, 6, 7 is 1, 3, 6, 7, 5, and the in-order traversal is 6, 3, 7, 1, 5, and the post-order traversal is 6, 7, 3, 5, 1. The code contains the structural node for the binary tree traversal, which is the traverse pre-order, traverse in-order, traverse and post-order. Then the sorting, bubble sorting of the bubble sorting. Then queuing. The third choice, queuing. Enter the first integer. For example, is 3, 5, 6, 7, and 1. The head of the queue is 3, deleting the head. The queue after the deletion is 5, 6, 7, 1, and the head of the queue after the deletion is 5. I have here from my partner. He presents on how it works, the queuing, in ordinary life. It shows from this code that queuing works in a C language code. The queuing here, and the queuing. Stacking. Enter the fourth choice, which is number 4. Enter the first integer, 1, 3, 5, 6, 7, which is the stacks is equal to 1, 3, 5, 6, 7, and the element on top is 1. Then for the fifth choice of the output is talk about in about. It contains the programmer which is my partner, Zardan Yunanyo, and the evaluator, and it's me, Homer the Padap. Then the sixth choice, which is the exit. End of the program, and thank you for using this program. And that's all. Thank you.